Hi guys, in this video we are going to configure access control list on our router. We are going to allow or deny traffic from going through a certain part of the network. In this case, we are going to block Facebook. Now let's get to it. The next thing we're going to do is we are going to start applying ACLs, meaning we need to restrict certain movement of traffic. Okay, with PC2, we want to deny access to the internet. We want to deny any access to the internet for this PC, which means that this guy, right, we don't want him to be able to access anything outside our network. He cannot Google, he cannot Facebook, he cannot do anything. He cannot communicate with any device outside the network, right? And then PC1, we want to deny access to Facebook only. So this guy likes Facebook, right? We want to deny him access to Facebook because he's not being productive lately. So he's always on Facebook. So we want to deny him just Facebook, but we want the rest of the information to still be available to him, right? He can Google, he can Instagram, he can ping, he can communicate with Meta over here, right? We want him to have all that access. He should have external services. Now, PC0 should be allowed all access. This guy behaves, so we know, we don't worry. We can let him have access to all of this. He won't abuse the resources. So PC1, nothing. PC2, selective, right? He can have some access, but not Facebook. PC3, he should get every access. So how do we do that? So we're going to start with this rule over here, the first one for PC1. Here's the thing. We don't have control on the computers this side. We cannot control them. This is the internet. We cannot have any control on this router over here. It could be Google's, it could be Facebook's. We don't know and we don't care. We can only control what's on our premises, which is this router and every device in here. So we are going to go to this router, right? We're going to configure our ACLs on that router. So the first rule is we want to block PCA from accessing the internet. It's confined to just this green border. So you shouldn't have access to anything outside the green border. So how do we do it? This is how you create access lists. So the first thing you're going to do is you need to be on the global config mode, and then you say config, access, right? Access, I just tab it. It will give me the full word, access list. Then there are two types of access lists. There is something called standard access list, right? And then there is the extended access list, right? We are going to be using the extended access list, and the reason for that is because the standard access list is limited. Here's the definition of the access list, or maybe not the definition, but just something you could know. Access list, the standard access list permits or denies packets based only on the source IP address, whereas the extended access list, right, permits or denies packets based on the source address and the destination address, protocol type, source and destination, TCP or UDP, and more. So it's extended. We can filter traffic using a more extended criteria, whereas this one, the criteria is only one. So we're gonna go with the extended, right? And the extended starts from 100. So these are the numbers. So 1 to 99, it's the standard list, but from 100 to 199 is the extended access list. So we are going to say access list, and then we're going to give it a number 100. We could give it any number, 143 if you want, but let's start at 100. It's more like a name, right? We're naming it 100. We're going to create only one access list that execute all those rules that I was talking about earlier, right? So all of them are going to be bunched up into this access list number 100. Access list 100, right? Deny, right? Now we're going to deny. Okay, if you go to deny and then you click the question mark button, or rather shift question mark, you will see it will give you all the possible commands that you add after that, right? You deny these services, right? These protocols. So we don't want to deny specific protocols. We want to deny all internet protocols, any internet protocol. So we're going to deny IP. If we wanted to deny pinging, which is the Internet Control Message Protocol, we could have just typed ICMP, but we want to deny all the IP protocols. So we're going to come here and say IP. So we have denied all IP protocols, right? And then if you do the same thing, shift and question mark, it will tell you what's next. What's coming as either you say the source address, which is this PC. So we want to define who we want to deny this to, right? We are denying it from this guy, right? So we could say any, but this will block all of the internal computers from accessing outside. So we just want one host, or we can say host. So there are two ways of doing this. You can type in host, right? And then the IP address, which is 192.168.1.10, because it's this PC2 over here. Or you can remove the host, right? And just type in, like I said, here you can type in the IP address straight away. You can type the IP address straight away and say .1.10, but if you do that, you have to give it something called the wildcard, right? The wildcard. The wildcard is more like a subnet mask. The access list wants to know how many devices in that network do you want to block. So we want to block just this device over here. So if it's just one device, we say 0.0.0.0. A wildcard is like the opposite of the subnet mask. If you wanted to refer to the one device, we would have used this would say we want this host only to be affected. If we wanted to affect the whole network, we would put a 0 over there like that, right? It will be a 0 like that, because this will say all the 255 hosts in this network should be affected. But like I said, it's the inverse. So we use 0, right? 0.0.0.0. This means one host. But I prefer to use the other method where you put the word host in front. It's easier. But anyway, we're not done yet. So let's continue. So what's next? Again, question mark. Now it says put in the destination address. So now we want to block this, right, from everyone, right? We don't want this to have access to anybody. So how do we do that? Do we type everyone's IP address? Do we type any, or do we type a host? Well, you guessed it, we type any, because we wanna, any device outside of our network should not communicate with this guy. So we hit enter. And if you go ahead and say, or do show access list, right? You can see here it says deny IP host. It converts this information to host, like I said before, host, this host, which is our host over here, any. So you are denying our source address any access to the external addresses or the destination address. That's what this means, right? We need to do the second rule now. And to do that, we need to understand what the rule wants of us first. So the second rule says deny access to Facebook only. So this guy, right, he likes Facebook. We want to deny this guy access to Facebook. So at the moment, as you can see, he can access Facebook, right? This guy can access Facebook. As you can see, voila, he can access Facebook. So now I'm going to close out. So we need to block this guy from accessing Facebook, but he still have access to Google and Instagram and any other services, right? Or pinging, he can still ping around. You can even still ping this device. You should still ping the device, because if he can also ping. So he should, after we are done with this rule, he should be able to ping but cannot access the website. We go to the router again, the same router, and then we say okay, we're doing the second rule now. So the second rule will go access list. We still call the same access list 100. We are denying, but this time around we are denying a certain particular protocol, not just all internet protocols, but a particular protocol, and this protocol is the TCP protocol. HTTP uses TCP, right? Because HTTP is the one responsible for the web browser. So we're gonna then type TCP over here. But let's see what else is next. So it's gonna say which source address. So we want to block this guy. We don't want to block all, right? We want to block only this guy, right? So we say the source address is our guy 192.168.1.11. not 10. We are done with 10. We are doing this guy now. Now, if you click the thing, it's going to say wildcards, right? So like I said before, I prefer to come here and type host. And I prefer to type in host. It's much easier, right, than wildcards. The next thing will be it says destination address, right? So which destination? Are we blocking him from all websites and other things? No, we're only blocking him for a particular service, and that service, it's in the host, in a particular host, right? Because it's coming from the server. So we're going to come and type in the host. This is the destination host, this is the source host, right? So now we're telling it the host of Facebook. So we type in that number there. Let me expand this a bit. So we're typing the Facebook IP address, but we don't want to stop other services from the server. We just want to stop the Facebook. If we leave it at that and hit enter, right, we will have blocked all the services from this thing, but we just want to block the Facebook website, right? This is a server. It could have other information. You could transfer other files like images or other things, right? It's a server. It can serve more than one function, right? So we just want to block the Facebook. So we use another tool called EQ, right? Let me do this. We're going to come here and use this EQ, function here, which just matches only packets on a given port number. So we want to go to a certain port number, and we all know that HTTP is under port 80. So we say EQ, and then we have an option. We can rather put the port number, say port 80, or we can write www, right? Those are the two options. So if I do this, you can see here with the question mark, these are the types of ports we can equate there. I don't know if that EQ stands for equate, but that's what I think it probably stands for. So we either type in www or we type in 80. I'm not sure if you can type HTTP. I've never tried that before, and I'm lazy to do it now since I'm recording and I don't want to mess things up. So I'm going to type what I know. So either you type www or you can type 80. It's the same thing, right? So I'll type 80 and then hit enter. So I only blocked Facebook. I didn't block Telnet. I didn't block SMTP. So you can transfer files, see file transfers. You can do other things like mails. If this server can serve mails and other things, you're only blocking World Wide Web, right? So we are very specific. This is the power of the extended access list compared to standard. You couldn't do this with a standard access list. So we hit enter, right? So now we have two rules in our access list. Okay, so if we go to our router, you will see that config t. So if I do show run, you will see that I have my access list here. It's already written, right? So this will block PC2 over here from accessing the external network, and this will block PC1 from accessing the Facebook web page, www protocol, right? So it blocks that. So we have these two rules written. However, these rules are not yet active, or they are not implemented yet, right? So we have to assign them to a port. Oh, by the way, another thing is there is something called let me type it here, something called an implied deny, right? Implied deny just means that whenever you write a rule or an access list, it will always assume that you are denying everything else other than what you have permitted or denied on top. You have to then come and then we need to come and say access list. Oh yes, access list 100. 3 options there. We have deny, permit, and remark. Remark is when you just want to put in a comment. So we're going to permit IP services because it denies everything. We want to permit IP services. these are the services we can, or protocols we can permit, right? These are routing protocols. This is pinging protocol. This is just TCP, and this is UDP. This is also another routing protocol. So we're gonna permit any internet protocol. All of this will fall under the internet protocol, right? So we want to permit everything. So we go ahead and say permit IP, right? So we're permitting IP from any source, any host, right? So we're gonna say any host, and now it wants us to give the destination and to any destination, right? So we're gonna come here and say any destination and then hit enter, right? So if you go back and say do show run, you will see 3 rules that have been added to the list, right? Now, as you can see, we're denying the first PC over here, we're denying Facebook to the second PC, and then we are allowing everything else. So PC 0 is not affected. He has access to anything thanks to this, because otherwise we were going to deny everybody everything, right? So we allow this guy to have access to the internet and anything that he wants. This guy over here, he will have the rest of the internet to exploit. It's just that he is only limited to Facebook. And this guy over here will not get any access. We blocked him to have any access, right? So we allow everything except this over here. That's what this means. So, but this is not the end of it. Like I said, these rules are just written, but they have not yet been applied. So if we go back here, you will see that this guy can steal Facebook, right? We blocked him to Facebook, but he can steal Facebook. If I type in Facebook, you will see he gets to the Facebook website. As you can see, he can access the web Facebook. And this guy over here, we denied him access to everything, but if you can browse, you will see that he can actually browse the internet. Let's say Google this time, google.com. See, he has access. So these rules have not yet taken effect, and the reason is because we have not yet applied them. So how do we apply them? We apply them on an interface. We choose an interface on the router where we want to apply. Sorry, the rule of thumb with extended access list, which is the one we are dealing with here, the rule of thumb says you should apply it closest to the source, meaning the source will be this is our source, and the destination is this side. Whereas with the standard, you apply it closest to the destination, right? So in this case, we're going to apply it closest to the source, and the closest we can get to the source is this interface over here. So I'm going to come and say we are going to apply the rules, and we do that by selecting an interface. So we're going to choose this interface over here, and this is called an inbound interface because from the source, the traffic goes inward into the router. So we want to block, or we want to apply the access list on the in the inbound side of the router. So we're gonna say interface G0/0. Now we're inside the interface. So we're going to go to IP, and then we say access group, right? Access group. So we're choosing the name of the group or the access list, which is 100. That's the access list. And then we have 2 options: inbound packets or outbound. We want to block the outbound packets. We want to block the inbound, meaning we're sitting on the router, we're looking out, right? So the inbound will be this direction. So we are blocking all the traffic going that direction, coming into the router. So we're going to say inbound, right? And then you hit enter. Now the rules have been applied. Okay, so now if I go and say do show run, you will see on our interface we have that statement there which enables, or it applies the rules. So the rules are now applied. That's one way to tell. And the list is down below. The list is here. This is the list that has been applied to that interface, which is gigabit Ethernet 0. So now let's test if this has taken effect. Okay, so now if I type in Facebook or any other website from this computer, I shouldn't have access. As you can see, it's taking forever. I can even come here and fast forward, and you can see it says hostname not resolved, and it's unresolved. So hostname unresolved just means that it couldn't access the DNS server. And if you try to ping the DNS server, you will realize that you can't even get to the DNS server. So let me ping 8888. See, destination unreachable. Okay, if we use the simulation mode, let's try that just to see how the packet moves. So we want to look at the ping. Okay, yeah. So if I say ping again, I'll use the same. So as I say ping, you will see when I try to run this that the packet goes through, but when it gets to the router, it gets blocked, and then there's a red envelope going back with a message saying you cannot go through, you've been blocked, right? So that's what happens. So the rule or the access list is working. So we can test this too. Remember, this should be able to access Google, right? So I clicked on my web browser. Now I want to access the Google website. Let's see. See, I can get to Google. I can get to Google, but I should not get to Facebook. So let's go back again. I can go to Google, but if I immediately change that, if I immediately change this to Facebook, I should have a problem. I should not go through. As you can see, it's taking forever. I can even fast forward. So it couldn't go through, right? So, however, this PC should have access to this PC should have access to all the websites, right? So we're going to start with Google, right? To google.com. There we go. We should have Instagram as well, right? .com. There you go. And we should also have Facebook, right? So as you can see, we have all the websites. Okay, so this guy can access everything. This guy is limited to Facebook, and this guy, he has nothing. So there you go, guys. Thank you for joining me. Please support by subscribing or liking the video, and also thanks for the patience. This was a little bit longer than I would have liked it to be, but thanks once more for joining me, and see you in the next video.